of that atom is the nucleus. What was it we found in the nucleus? Protons. What else did we find in the nucleus? Neutrons. That's where all the protons, all the neutrons are found. And then out around that, we have the energy levels, also called in some books energy shells, but they use level and shell interchangeably. And this is where we found the electron. Okay, now that's kind of a schematic of it. Here's what you can think, although this is an way oversimplified picture. In the very center of the nucleus is this tiny sphere, because atoms are three-dimensional. That's your nucleus. Then, in concentric spheres out around that, the energy levels. And so what I've drawn for those energy levels is just an arc on the surface of the sphere. So we're talking here. Here's a sphere. Okay, here's the first major energy level. Here's the second major energy level, the third, and so forth. And we're going to name these. Now, these are the major, sometimes referred to as principal energy levels, meaning the main ones. And we use cleverly. They started with number 1 and built out from that. In the old days, they used some letters of the alphabet for that, but they don't do that anymore. It's just, if you're closest into the nucleus, you're on the first major energy level. If you're on the next level out, you're on the second major energy level. And what's interesting, some characteristics here, the nucleus, all positive charge is found in that nucleus. And essentially all mass is found in that nucleus. We come out to the energy levels though, all negative charge is found out there, and essentially no mass is found out there. Okay, but the other thing, and this is the part I haven't mentioned yet, essentially all volume is due to the energy levels. Essentially no volume is due to the nucleus. In other words, this is just another way of saying the nucleus is really tiny, and what determines the size of an atom is really where those energy levels are. Some books you read will say the nucleus is 1/10,000th of the entire atom. Some books you read will say 1/100,000th of the atom. But here's an analogy. Think of a football stadium. Think of Reliance Stadium. Think how big that is. Okay, if that represents one atom, that entire football stadium, if you took a cherry pit or a small seed of any sort, you took that cherry pit, put it in the middle of the 50-yard line, that would represent the nucleus. And that gives you some size feel. That the cherry pit, the nucleus, tiny, tiny. The entire atom is like the football stadium. So we're talking small. So know some of your characteristics here. Really, really tiny, but has all the mass, which means really, really dense, doesn't it? Small volume, large mass. But what we're interested in, the electrons and what they are doing, where they are, because that gives us so much power to predict what's going to happen. Remember that first week of school, I think I probably said at least once, the action in regular chemistry or ordinary chemistry is with the electrons. All the chemical reactions that they're doing up there on the shift channel, they're playing with electrons, and that's what we do. Only people at nuclear reactor sites or nuclear chemists, nuclear physicists actually mess around with the nucleus. So, the name of the game for us is electrons. They're either given away, they're stolen, or they're shared. So that's why all this emphasis, a whole chapter almost, about electron configurations. Where do we predict they are? Okay, so the first thing we have is this major energy level. And it's denoted with a capital M. It starts at 1, uses integers only, and in theory it goes to infinity. In reality, it only goes to about 5 or 6. Okay? So, major energy level. Now, it's been found is there's a maximum number of electrons that can fit on any particular major level. And we talk about this idea. Aufbau idea, and I can't think right now if the A comes first or the O comes first. Check me out in the book if anybody sees that. Aufbau principle. I got it right? You ever write a word, you look at it, and you can't think, is that right? It looks wrong?
A-U.
A-U, oh, okay. That's why it didn't look right to me. Aufbau. It's a German word. Even though I passed German years ago, I still can't say it or spell it, except to ask for a glass of beer. I can do that in German. Okay, Aufbau is a German word, and it means building up. And we're going to be looking at that all through this electron configuration. Because here's what happens. The electrons are negative. Who do they love? Something positive. So the best place in the house is on the first major energy level. But if we can think of it right now as a sphere of a certain size, so there must be a maximum number of electrons that can be accommodated there. And if that's full, then they got to go into the second place in the house, best place in the house. Okay, an analogy for this class. Let's say, you knew we were going to have this musical chairs here right after test 1. Let's say all of you, I know this is a lot, but let's say all of you want to sit in the front row. Because, hey, that's where the A students sit, right? So you want to sit in the front row. So that day when we had a change of seating, what do we have? 6 places? Okay, the first 6 people that got here got the first row. Okay, the 7th person that walked in the door really wants to sit in the first row, but it's full. Tough luck. You got to sit in the second best place in the house, and so on. Okay, now probably more realistic. What if it's a rock concert and the auditorium is a V like this? So the first row only has 2 chairs in it. Okay, the second row has more chairs in it. So if you get there first, it's open seating. You don't have a reserved seat. First 2 people get to sit right on the front row. Throw their underwear at the stage or whatever. They will do that. Okay. So Aufbau. We want to get to the best place we can. But someone discovered that there is a relationship, and the relationship is 2n squared. 2n squared. And they just kind of stumbled upon this. Okay, if we are on the first major energy level, so n is 1, and this tells us the maximum number of electrons that can be accommodated there. The 2 is always there. The n is what changes, and then we square that n value. And so this tells us how many will fit on the first major energy level. 2. Once you have 2, it's full, just like the concert. 2 seats in the front row. Yeah, Andrew?
Why is there 1?
Because I chose that we're on the first major energy level. Okay? Now, I'm going to the second. See, this is just a little table I've set up. Okay, so if n is 1, we can fit 2 electrons there. If n is 2, how many can we fit? 8. Now, doesn't that make some sense? Because if you're thinking in terms of, here's the nucleus, here's your first sphere. That's really not this simple, but we can think simply here. 2 will fit. Then your next sphere is larger. You can accommodate more. So let's go to the third. I'm on the third major level. How many?
18.
18, because 2 times 3 squared, 18.
So when you're working with these, I mean, what level do you normally go to?
Okay, it depends how many electrons you have. If I have 1 electron, like hydrogen does when it's neutral, it's going into the first major energy level.
Right.
Helium has 2 electrons. Well, whoopee, they both get to be in the first major energy level. But lithium, look where lithium is. It's got 3 electrons we need to place. First 2 go to the best place in the house, full. It's got to go into the second major level. Okay, so, nice test question. I'm on the 5th major energy level. How many electrons fit there maximum? I'm on the 5th. 50. 2 times 5 squared, 50. Okay, so that's first kind of easy, supposedly easy test questions. How many will fit there? It's going to be an ever-increasing number, and how do you know that? Because somebody was clever enough to see patterns developing. Okay, everybody comfortable with that? Starter idea. Okay, then, it was discovered as the instrumentation got more sophisticated, there were actually sub-levels on these major levels. And luckily, there was a tremendous pattern to this. If there weren't a pattern, this would be impossible to study. If you're on the first major energy level, they just found 1 sub-level. Now, if you could make the philosophical argument, if there's only one there, why do you call it a sub-level? But they do. Okay, there's 1 sub-level. If you're on the second major level, they found 2 sub-levels. If we're on the third major level, they discovered 3. What if we're out here? What if I'm on the 4th major energy level? Take a wild guess how many sub-levels they found there. 4, exactly. Okay, another test question. I'm on the 10th major energy level. How many sub-levels are you going to find? 10. Okay? Pick up the patterns here in life's amazing. Yeah, Marco?
I'm sorry, why they found 4 sub-levels? Did you draw the 3 lines?
Put in line.
3 lines,
Oh,
yeah.
little tiny sub-levels, like, you can think of it. It's going to be more complex later.
Yeah.
Little tiny spheres that are really close together. Okay? You know, instead of just one big one.
Mm-hmm.
Okay, here I am on the first, and there's just this one.
Right.
I'm out here on the second now, but it's really 2 little spheres that have a pretty nearly the same radius. Okay? But again, I'm simplifying this a lot.
It's kind of like a lot of spheres inside of a sphere.
Yeah, but it gets more complex than that, yeah.